Good morning, students. In this video session, I will cover the last part of your syllabus, Unit 1, that is flowchart. Flowchart is defined as the pictorial or graphical representation of an algorithm. So, flowchart for a given algorithm consists of a complete diagram of boxes or standard shapes connected by directed line segment. By drawing a flowchart, the algorithm can be better understood and can be convinced to others very easily. As we already know, image speaks louder than words. That means instead of giving a page full of information, just by drawing 2 or 3 lines, we can convince or convey our idea to other persons. The same concept applies for the flowchart also. So, flowchart is the not the final step, it is just an intermediate step. So while developing any program, algorithm is first developed, and how the algorithm is executing or how the flow of execution is going on or will be done during the execution of the program is visually represented by flowchart. Then actual coding is started. So this is the intermediate step, and whatever may be the size of the coding, whether it's very small or medium or highly complex, flowchart plays an important role in developing the software, because in many times without before reading, that means after understanding the algorithm, the developers will look for the flowchart while developing the software coding. There are two types of flowcharts. One is program flowchart that specifies only the algorithms. That means the basic idea of the problem solving, and it is diagrammatic representation of the given algorithm. Whereas in the system flowchart, here entire view of computer system is considered, that is along with the pictorial representation of the algorithm. For example, we we have given the statement for inputting and outputting the values, but how this done in the system or computer in the internal working of the computer is not specified. We'll just write read num or print num, but in system flowchart it also specifies what are the module of the computer hardware and software part take part in the execution of the computer program. So it shows diagrammatically the total environment of computer on which given algorithm is solved. So here is the symbols. Actually it contains more symbols than here. So these are the many symbols which are frequently used in simple flowchart development. So every flowchart starts with a terminator, and this is for start and as well as stop. Any action or process that is taking will be represented by a rectangular, and decisional steps is specified by a diamond shape here is, and it has two arrow symbol which indicates whichever will be the which step will be taken based on the result. Here is a condition will be used. If the condition is true or yes, one step will be taken, and if condition is false or that is no, then another step will be taken or flow path is considered. So we'll understand this much better in the examples. Inputting and outputting operation is specified by parallelogram symbol, where we'll write the input or output statement. Different parts of the flowcharts can be connected, so that is there will be a meeting point. So if the different flow of executions If you are meeting at a specific point that are specified by a simple circle, that is also known as connector. For preparation work or iteration related steps, we will use this type of symbols, let's say rhombus series, and for document we will specify this type of symbol. So usually these are used in system flowchart, and to specify the internal storage, magnetic tape are specified by these symbols, and arrows are indicating the flow of operations. So now we'll go for simple example. There is, this one is the first example algorithm given to you already in the previous sessions to compute sum and average of three numbers. So read three numbers, find their sum, find average, and print the sum and average and exit and the algorithm. So this is specified in the flow chart like this. There is the start, that's the beginning of the flowchart, and stop, that's the same symbol but we have written it is start. Here is input and output statements, that is read and print, specified by parallelogram, that is read n1 comma n2 comma n3. And here is the processing step. Here addition and division operation are done. You may give in the same box or in different box. It's better to give individual steps in separate boxes. So here is sum is assigned with the result of the addition operation, that is n1 plus n2 plus n3. Likewise, sum divided by 3 is the division operation that will be performed and its result is assigned to average. And the print, that is output statement, print sum comma average, and this is the end of the flow chart. And here is the second one. So that is flow chart for example 2 to find area of triangle. It's very simple and easily understandable to you. We will input two variables here is compute area and prints the area and end of the flow chart. Likewise, here is to compute the simple interest for a loan. We will input the principal amount of the loan, rate of interest for the loan, and year for the duration of the repayment of the loan. And by using the simple formula, that is whatever the values we have stored in the program, that's the same variable we are using, PRI star ROI star year divided by 100, that will be the SI. Actually it should be left arrow symbol SI. So print SI, then stop. So this is the algorithm, flowchart for its simple interest for a loan. And fourth one, that's the most, we will put two values and their values must be swapped, that is exchange, must be exchanged. So we will input two values stored in x and y. I will store value of x in temp, then I will assign the value of y in x, and temp value, that is the previous value of x, that is assigned to y, and finally we will print the value of x and y. So after these three steps, the value of x and y are exchanged. And this is the fifth example where we will check for the odd or even property of the given number. The program is algorithm is very simple. Flowchart is also easily understandable. Start, beginning of the algorithm, we will input a number and we will perform a modulo operation on num and 2, that is num value is divided by 2 and remainder is stored in the variable rem. Here is carefully observed. In algorithm I have written if, and here written here is. This is a convention writing for selection statement, that is using the diamond. Even in some books they are written if both are correct, but the usual practice that you have to write is, and here is the comparison, and in the third line that is question mark. So is rem equals 1 question mark next line. If this condition is true, that is yes condition, then the flow of execution is selected on this line. If the condition is false, that is if rem is not equal to 1, then flow of condition is selected from this direction. So if rem is equal to 1, that is yes, so the flow of condition execution will start from this direction. Here it will gets one statement, output statement, that is print given number is odd. So if remainder is equal to 1, that means it's odd, so this statement will execute. Likewise, if the remainder is not equal to 1, that means it is always 0. So if it is 0, that means given number is even. So this is a simple logic. So after executing any one of these statement, it should come to stop. So here is a connector point. So after the execution of this statement or this statement, it should come to stop here is. So I will put one connector here is. So this is the method. So again observe here is from start to here it is sequencing, and from here to here it is branching. It is called, it is branching. The same one, fifth example, but with improved logic. The reason is that in the beginning of the coding we will teach what is the odd property, or how to check the given number is odd or even. The logic here is we will divide it by 2. If the remainder is 0, then it is odd even number. If the remainder is 1, we will consider given number is even number. So in the improved logic, we will check for whether the given number is odd or even, along with whether the given number is 0. The reason is that 0 is not an even, not an odd number. So if we divide it by 2, then we will get the remainder as 0. So we will consider 0 as even, that is it is divisible by 2. Actually in the 0, that's the value is 0, is not an even, not an odd number. So we will put one additional condition such that if the given value is equal to 0, then display the message given number is 0, then straight away go to the end of the algorithm, that is in our case that is flowchart. If it is not equal to 0, that is no or false, then I will go for remainder operation, that is modulo operation. I will divide it by 2 and remainder is stored in RAM. And here is if the remainder value is equal to 1, then that is yes, print given number is odd. And here is if it's not equal to 1, then print given number is even. And these two statements will join here. Only one of them can execute here is, and again another connecting point here, and finally stop. There are three flow of path, that is one is here is if number is equal to 0, then it comes and ends here. Next one is here is if the given number is odd, then it starts here and moves in this direction, then ends here. And if the given number is even, then it starts here is and the path is selected in this way and comes to end of the flow chart. So three different flow of execution is there. If it is 0, it straight away display the message and end the reaches the end of the flow chart. The care should be taken is that while writing in algorithms, we will write go to step 5. If given number is equal to 0, go to step 5. But there is no such type of step numbers in flowchart, so we will connect the next line, so that's the next step, by using arrow symbol and with the connector. Sixth one, that is to find biggest of, that is largest of three numbers. Here we will input three numbers, and initially I will assume the first number as the biggest one, that is a value of num1 is stored in large, then value of num2 is compared with the large. If it is true, then value of num2 is assigned to large. Similarly, same comparison is done for num3, and finally I will print the value print, that is large. Pictorially it is represented like this. Three values are inputted. I will consider first number as the largest one, and in the next step there is conditional statement, that is num2 value is compared with large. If it is true, then value of num2 is assigned to large, and after this it comes to next point here is. If it is not large, straight away go to next point, that is no, and the connector point. So the second comparison, if it is true, then num3 value is assigned to large, then comes to connector point. Otherwise no changes here is directly comes here is. So after these statement, that is for first assignment and two comparison, I will get the largest value among these three given input. And here is flowchart for the seventh one. This is same as that of the order even. Only the difference is that I will check for divisible by 7 or not. In order even, I will divide it by 2, and here it is, I will divide it by 7 and check the remainder. If remainder is 0, that means given number is divisible by 7. Otherwise it is not divisible by 7, then finally end of the flowchart. This is for iteration, that is repetition of group of statements. This is for to find the sum of odd numbers from and even numbers from 1 to 100. I will initialize the variables with zeros, that is sum even is equal to 0, that is, and sum odd is equal to 0. So in flowchart also I given like this. And here is, I will use one repeat construct, repeat for I equals 1 to 99. I will take the beginning number here is 1 and last number is 99, and the value of I is incremented by 2, that is in steps of 2. Initially I will take the value 1 and value of I is added with the existing value of sum odd, and the same is assigned to sum odd. Value of I is changed, that is specified by next I. So if the value of next I, that is next I, is not greater than 99, then it goes to beginning of the iteration. Again its condition is checked. So if does not cross the given range, then goes to next line, and this process is completed and again goes to next. So this is continued till I becomes 99. After this there is no next, it directly comes to next statement after the next construct. So here is again one more, that means after this iteration sum odd will contains the sum of odd numbers from 1 to 100. It is actually not 100 up to 99, because I have started from 1 and 2 is added, that is 3, that is I will take the value 1, then it will become 3, then it will become 5, then 7, 9, 11, likewise it increases up to 99 in steps of 2. The same logic is used for the sum of even numbers. Here I value started from 2, increased by 2 each time, and this is done until I becomes 100. And every increase in I results in adding it to the existing value of sum e1, and the result of this addition is again assigned to sum e1. And after this, I is incremented by 2, so as it is specified in step of 2. If it does not cross 100, then it goes to again beginning of the loop. So this process continued until I is 100. After that, the loop execution is terminated, goes to next statement. So we will have print sum odd comma even. So this is the given example in the algorithm ninth one, that is to find factorial of negative value, non-negative integer value. So this step word is very important because we can't find calculate factorial of negative integer. Factorial of 0 is 1. This is very important point, and factorial of any other positive value can be calculated. So the logic is that input the given input the value, initialize the variable fact by 1, and by using a iteration construct multiply value of I with fact, and multiply result must be stored in the same variable. So value of I changes from 1 to num in steps of 1. That means it is incremented by 1. So if the value inputted here is 3, then I takes the value 1, then 2, then 3, and it is multiplied. So value of fact here is initially 1, it multiplied with the value of 1, then again I is incremented by 2, that is multiplied here is 2, and again I incremented by 1, that will become 3. So finally loop ends. So after that I have the result, that is 1 into 1, that is initial value of fact, that is, so no change in the multiplication. Afterwards I take the value 1 2 3, that is 1 into 2 into 3, that is 6. So factorial of 3 is here is 6. So finally we will get the value of fact in step 5. Then end of the algorithm. In flowchart is very simple. Start beginning of the flowchart, and here it is. Input the value, that is num. Initialize fact with 1. Then repeat for I from 1 to num in steps of 1, and multiplication is done, that is existing value of fact with the value of I, and its result is stored in again in the same variable. Value of I is incremented by 1 because we have specified in steps of 1. So this process continued until I takes the value num. After the crossing that value, loop execution will be terminated, then goes to control of execution goes to next line, that is print fact, then stop. This is the last one. To check the prime property of the given integer value. Prime number, you already know, it is a number divisible by 1 and itself. So to check whether it is divisible by the given number is prime or not, we have to divide that given number from 2 to 1 less than the given number. So if 13 is considering as the prime number, then we have to divide it by 2 and 3 and 4 up to 13 minus 1, that is 12. So in all these division operation, remainder is not equal to 0, that means given number is prime number. So the same logic is used here is read num, then repeat for k. Observe here is you can use any variable name, need not to use I always. 2 to num minus 1 in steps of 1. I will divide it the num from value of k, that is modulus operation, and remainder is stored in rem. If rem is equal to 0, that means number given value num is not a prime number, it's a composite number. It is divisible by a particular value of k. So I will display the message given number is not prime, and go to step 4. Step 4 is here, that is last. But in flowchart we can't write like this, we have to depict the skipping of statement by arrows. And here is if rem is not equal to 0, then next k. So in the next k again I is incremented by 1. This process continued until I becomes, that is, so not I, it is k. So k takes the value up to num minus 1. In any of these state iteration, if remainder is not became 0, so this statement will not execute. So we can say that given number is prime number. So I will print the next statement, that is given number is prime number, then end of the program. So initially this logic may be confusing for some students. This is well explained in the flowchart. Observe, here is given value, that is read num. I will repeat, that is k value from 2 to num minus 1 in steps of 1. I will perform a modulus operation, that is value of num divided by value of k, and result, that is remainder, is stored in remainder. And here it is, if remainder is equal to 0, print given number is not prime number. So remainder should not be 0. If it is equal to 0, then given number is a composite number, it's not a prime number. So given number is not prime number, then directly bring the flow of execution to end of the algorithm. So this is depicted, so explained in the algorithm by step. Go to step 4, but I can't write step number in flowchart. I will depict it to the flow of direction by the arrows. If it is not equal to 0, next I, so next k, actually it should be next k, and value of k is incremented by 1, and again performs the modulus operation, and remainder is extracted and it is checked with 0. If it is equal to 0, it's not prime. Otherwise, again go to next value and increment the value of k, and this process continued up to k becomes up to num minus 1. It should not be num, it should be num minus 1, because if it became num, then I will get num mod num, so I will get the remainder 0, so our entire logic will collapse. So k should take the value 2 to num minus 1, and if this condition does not satisfy for any of the k value, that means given value is prime number. So it goes to next statement, given number is prime number, and stop. So this is simple connector, just to connect two different flow of execution point at a common point. Okay students, these are the some example for flowchart. So now, in the previous session, I have given two sets of algorithms as exercises. You have to solve it. For the same, you have to write the flow chart. See, the same I given here is the flow chart to write flow chart for the algorithm to find product of two numbers, next area and perimeter of rectangle, next volume of a rectangular box, then flow chart for the algorithm to convert given Celsius temperature to Fahrenheit temperature. The formulas I have already given in the previous video. Then print all even numbers from m to n. So you have to specify the beginning number and last number. Then sum of numbers divisible by 9 from 1 to 50. Then flowchart for algorithm to print first n Fibonacci number. So what is Fibonacci number is already explained in the previous video. Just go through it. Then finally, the flowchart for the algorithm to find largest given n input numbers. Here you have to input n values and find the largest among them. Okay students, here it completes introduction for flowchart. Thank you.